Let's apply our understanding of parallel and perpendicular lines to find some missing values together. Alright, so for number 1, we know we have a line that's going to pass through the points of 3k, 6k minus 5 and -1, -7. Let's call these two expressions x1 and y1, and we'll label these as x2, y2. Next, we're told that this particular line has a y-intercept of -5, which just means that we're going to have a point of 0, -5 on this particular line. Our job is to find the value for k, as well as the equation of this line. Alright, so we really have three sets of x and y. We have this ordered pair, but it has k in it, so we can't really tell what's going on with it yet. Then we have this ordered pair, which is useful because we have both numbers. And then we have this third point, which is going to be the y-intercept for this equation. Since these are the 2 points that we know the actual x and y coordinates, let's go ahead and use those first to find the slope of this line. Just to keep things nice and organized, I'm actually going to call this 0, -5 or x3, y3, just so we have things nice and organized. Using these 2 points over here to find slope, we can use the formula of y3 minus y2 over x3 minus x2, and then if we go ahead and substitute in our numbers, we're going to get cleaning this up a little bit, -5 take away -7 is going to be a +2, and in the denominator 0 minus -1 is going to be +1, so we know the slope of this line is going to equal 2. So actually at this point we can find the equation of the line right away. For the equation of the line, we just found out that the slope, or m, was equal to 2, and because we know the y-intercept is -5, we know the b value for the slope is going to be -5. So if we go ahead and plug in this information into our slope-intercept form, or y is equal to mx plus b, we can go ahead and write the equation of y is equal to 2x minus 5. This is the equation of the line. Now that we have the equation of the line, let's go ahead and find the value for k. So let's use that information over here. We're going to use this y2 minus y1 over x2 minus x1, and let's go ahead and substitute some values in, including the slope, which we know is going to equal 2. So 2 is going to be equal to m here. So this is what we get when we substitute in, so let's go ahead and just clean this up a little bit and distribute these negatives. Distributing these negatives, this is what we're going to get here, and then if we go ahead and just combine some constant terms in the numerator, we can go ahead and write that 2 is equal to this -6k minus 2 over this -1 minus 3k. Alright, I believe this is as clean as we can get this equation, so let's go ahead and see if we can just solve for k now. Rewriting this 2 on the left, we can rewrite it as 2 over 1 so that we can go ahead and use cross products here. Multiplying those cross products together, we're going to get this equation right here. And then if we distribute, we're going to get this equation right here. Then if we go ahead and add 6k to both sides, we're going to find out that -2 does indeed equal this -2. And so what we can conclude is that for this particular problem, k equals all real numbers. So you can go ahead and plug in any value for k here, and you will find another point that will be along this line. Alright, let's try one more. In this problem, we're going to have a line that's going to pass through the points of k plus 9, -4k minus 3, and -2, +1. I'm just going to start by labeling these as our x1, y1, and these as our x2, y2. When they tell us we have a y-intercept of 9, that means we're going to have a point of 0, 9 along this line as well. And just to label everything, we'll call this x3 and y3. Now, just like in the last example, our job is to find the value for k as well as the equation of this line. Just like last time, this is too scary and complicated to use first. So let's just focus in on using these 2 points here. Let's set up an equation to find the slope of the line that goes through these 2 points. So we have m, or slope, is equal to y3 minus y2 over x3 minus x2, and if we go ahead and substitute in these values, we're going to get 9 minus 1 over 0 minus -2, and if we clean this up a little bit, we're going to end up with 8 over +2, which is just equal to a slope of 4. Now that we have the slope of this line, I think we have enough information to write the equation of the line. Since we know the slope is equal to 4, and the y-intercept of 9 lets us know that the value for b is going to equal 9. Plugging these two values into our slope-intercept form equation, we can say that we're going to have y is equal to 4x plus 9. This will be the equation of our line that's going to go through all of these points. Alright, so we have the equation of the line now. So let's focus in on finding the value for k. Now we'll finally use this information over here. And to make our lives a little bit easier this time, let's actually use this x1, y1 and x3, y3 so that we can take advantage of the fact that we have a 0 here. So setting up an equation here using this point and this point, we can write that m is equal to y3 minus y1 over x3 minus x1. And then if we go ahead and swap out this 4 for m, we can go ahead and write that 4 is equal to this 9 minus the quantity of negative 4k minus 3 over 0 minus the quantity of k plus 9. Then if we go ahead and distribute here, we can say that 4 is going to be equal to this 9 minus this negative 4k, or that's going to turn into 9 plus 4k. And then we have a subtracting minus 3, so we're going to say plus 3. And this is going to be all over 0 minus this k, and then minus 9. Then if we just go ahead and combine some like terms in the numerator, combine these constants, we can clean this up and write 4 is going to be equal to this 4k plus 12 in the numerator. And then in the denominator, we're going to have this negative k minus 9. Alright, so I think this equation is as cleaned up as we can make it. Let's go ahead and now solve for k. Now to do that, I want to use cross products here, but feel free to use another strategy. Let's go ahead and write this 4 as 4 over 1. So if we do that, we have this equation right over here, and then we can go ahead and use cross products to get rid of the fractions and write this equation right here. And if we go ahead and distribute, we can get this equation right here. Then if we go ahead and add 4k to both sides, we're going to get negative 36 on the left side, and then we're going to have this 8k on the right side plus the 12. Subtracting 12 from both sides, we're going to get negative 48 on the left side is equal to 8k on the right side. And then finally, if we divide both sides by 8, we're going to find out that k is going to equal negative 6. This will be the value for k that makes this equation true. So if k is equal to negative 6, we can go ahead and plug that back into each of these locations here. And so that this point that we have, if you plug in negative 6, will be along the same straight line that goes through negative 2, 1, as well as 0, positive 9. And just for good measure, if you want to see what this looks like on a graph, it would look something like this, where we were given this negative 2, positive 1, the y-intercept of 0, 9, and if you plug in that negative 6 into that first expression with the k values, we're going to get this 3, 21. And this equation for y is equal to 4x plus 9 hopefully makes sense because we see a y-intercept of positive 9 right over here, and we do have a positive slope of 4, so this line is going up 4 and to the right 1 as you are moving up and to the right for this graph. Alright, so that wraps up this video where we practice using our understanding of linear equations or linear lines as well as slope, and we found out some missing values of k. If you found the video helpful in any way, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.